This is exam 1, numbers 12 and 13. In this video, number 12 and 13 both concern the same graph, and so we will do both of them in the same video. Well, first of all, it gives us a graph that looks a lot like this. It gives us a y-axis, and it gives us an x-axis. Here's our x-axis. And it has some, gotta label some important values on the x-axis. I guess this will be 1. I'll go all the way out to 8. 2, 3, 4, 5, 6, 7, 8. It of course also has some y values here. I'll call this y equals 1, 2, 3. And the graph is doing something like this. The graph comes something like this here. It goes to x equals 2, goes up to x equals, at x equals 2, it goes up to f of x equaling 2, so it's doing something like this. But at the value x equals 2, the function itself actually happens to be 1. And it seems to increase linearly until we get to x equals 3. So it does something like this here. And after that, at x equals 4, it actually sort of begins down here near the x-axis. It rises, seems to be up to y equals 1, so it rises up to about here. At y equals 1, the function does something like this. And then after that, it increases something like this. Okay? So here was the graph that was presented to you in number 12 and 13. And so now let's concentrate on number 12. Number 12 asks us to find the limit as x approaches 3 of this function f of x. Okay, well, let's look at it very carefully and think about what's going on there. I'm going to switch a different color so I can write on the graph and not confuse you. So the blue ink here is the graph itself, and I will be writing on the graph in red to communicate my thoughts as I'm speaking to you. So, this limit as x approaches 3, right there, right here is where x equals 3. But there are two ways to approach x equals 3. You can approach x equals 3 from the left-hand side, coming at it from the left, and you can approach x equals 3 coming at 3 from the right. And to think about these limits, you need to think about what is the function doing as we get closer and closer to 3 from the left and from the right. Well, to begin with, let's look at what's happening as we approach 3 from the left. So the limit as x approaches 3 from the left of f of x means these are the values of x that are to the left of 3. So, for example, 1 and 2 and 2.5 and 2.9 and 2.99 and 2.999 and 2.9999, and well, you get the idea. Well, as x is our value is like 2.9 and 2.99. What is the? Can you see here? Maybe this is at 2.5. The graph is right there, and at 2.9 the graph is right there, and it seems that the graph is getting closer and closer to 2 right there. It seems the graph is getting closer and closer to 2 right there. So the limit as x approaches 3 from the left of f of x seems to be 2. What about from the other side? What about, I'll switch colors again. Maybe a nice green color. Can we do that? Okay. Yep. So let's look at what about the limit as x approaches 3 from the right. So these are values that are getting closer to 3 but coming at it. So for example 5 and 4 and 3.5 and 3.1 and 3.01 and 3.001 and 3.0001, and I think you get the idea. So as we get closer and closer to 3, so right there's 3.5, and right there we are on the graph, and now at 3.1, maybe we're right there, and 3.01, and do you see how these x values are getting closer and closer? On the graph it's getting closer and closer to what seems to be, oh, right there, y is 0. So the limit as x approaches 3 from the right of f of x seems to be 0. Compare the left-sided limit with the right-sided limit. On the left-sided limit seems to be 2, the right-sided limit seems to be 0, and since they are not the same, we say that this limit, the limit itself, does not exist. That is, the limit as x just approaches 3 of f of x does not exist. Okay, let's take a look now at number 13. Number 13 uses the same graph and asks us to find the limit as x approaches 1 of f of x. Okay, well again, let's use I'll go back to the red ink for the left-sided limit. So the limit as x approaches 1 from the left, that means values that are to the left of 1. So for example, 0 is to the left of 1, but so is 0.5 and 0.8 and 0.9 and 0.99 and 0.999 and 0.9999, and I think you get the idea. So as we get closer, as the x values get closer and closer to 1, never getting there, but closer and closer to 1, what's happening to the graph? Well, right there is where we're at 0.5, and maybe this is 0.6, and right there is 0.9 and 0.99. It seems that the graph is getting closer and closer to y equals 1. So it appears to me, using this graph, it appears that the limit as x approaches 1 from the left of f of x is 1. Let's compare that with the right-sided limit. I'll switch over to the green ink. So here, let's find the limit as x approaches 1 from the right. See, these are values that are to the right of 1. So for example, 2, but also 1.5 and 1.1 and 1.01 and 1.001 and 1.0001. You see, we never have to actually get there, but we're getting closer and closer. So we have these values. So at 1.5 it looks like we end up right there on the graph. But what about 1.1? Well, I'm right there on the graph. And then 1.01, what am I getting closer to? What is the graph getting closer to? It looks like the graph is getting closer again to y equals 1. So the limit as x approaches 1 from the right of f of x seems to be 1. Now compare the left-sided limit and the right-sided limit. They are the same, and so we can say that the limit, this limit, as x approaches 1, not specifically from the left or from the right, but just as x approaches 1 from either side of f of x, is equal to 1. So here is our answer. Here is our answer for number 13, whereas this was our answer for number 12.